Good morning to all of you. Shall we start? Why again?
Okay, sir.
44 only. Okay. Lecture is over, na? Previous lecture?
Yes, sir.
Yes. Many of the people join late. That's why I'm asking. Huh? So I think in last lecture we have seen that int-con register or not. Hello. In last lecture, which register we have studied? Hello. Hello.
Sir, int con.
Int-con complete, na? Okay.
Yes, sir.
Okay. So in today's lecture, we will discuss related to the next SFR, and in that first, that is today's first SFR is PCON, Power Control Register. In that, only 2 bits are used now, okay, and remaining bits are now it is not used, but it may be used after modification in architecture or adding some additional bits to the these SFR. So till now, we will discuss related to these 2 bits available in PCON, that is power control register, and the bits are brownout reset and power on reset. So related to the reset condition, here two different states are defined. That is, first one is BOR, brown out reset, and second one is power on reset. So based on the status of these bits available in PCON, we are able to analyze or assume that which condition has been occurred. Okay, so these 2 bits, or simply we say that flags, are active low flags, as bar is mentioned, BOR bar, POR bar. So if we consider the first bit, that is D0's BOR, brownout reset status bit, it will gives us the status whether the brownout reset has been occurred or produced or not. So if, as this is a active low signal, so when brownout reset has been occurred, it will become 0. So BOR bar is equal to 0 means BOR is equal to 1. So it will detect that brownout reset has been occurred. Otherwise, this bit default sets to the 1. Okay, so here brownout reset, as we have already discussed, that when your supply voltage reduces less than 2 volt, as normal conditions where our controller with the different packages works from 2 volt to 5.5 volt. So whether DIP is there, SMD is there, PLCC is there. So based on these various packages, SMD or leaded IC, that is leadless, leaded, or SMD, three major types related to the pin configurations. So based on these configurations, so minimum required voltage for a PIC controller is 2 volt. So when the supply voltage reduces below that, the minimum required voltage, that is less than 2 volt, in that case brownout reset has been detected or occurred. So whenever your device, that is system or a particular controller, resets, in that case, if BOR bar activates, here we use the word activates, that is initially it was 1, but whenever brownout reset occurs, in that case it will becomes 0. So we will analyze that or assume that brownout reset has been occurred. So variation in supply for our understanding. Or if this bit is not activated, that is as default it is 1, so remains it is 1 after reset also, then brownout reset condition has not been occurred or produced. So we have to analyze that brownout reset is not happen. Okay, so related to that, if you want to make some modifications in your input, that is supply. In that case, we have to study this bit, that is BOR bit. Okay. Otherwise, if this bit initially 1, after reset also this is 1, then no problem in the power supply. Okay. After that, second bit we will consider POR, power on reset status bit. In that case, this is also active low signal, and initially it was 0. Okay. It was 0. That is, whenever we turn on first time, okay, or after some time, so this bit initiates reset condition to the controller. Okay. So whenever, as a name itself, power on reset. So whenever we want to turn on your system or controller, at that time it will produces or resets the system along with the controller. So whenever controller is resetted, automatically your total system is resetted. Okay. So when this bit is equal to 0, power on reset occurred, and when this bit is 1, power on reset not occurred. Okay. So for producing the reset at the time of power on, this bit uses, that is, for that purpose you have to make this bit is equal to 0 whenever you want, whenever you want reset your system at the starting time, that is whenever we turn on our device. At that time you should make POR bar is equal to 0 in a system. Otherwise it is not necessary to make POR bar is equal to 0. Okay. If you do not want to reset your system. Okay. But in most of the cases, programmer or a system user requires power on reset condition, as sometimes there may be a stuck in the system. Due to this, your functional operations did not completed successfully. All malfunctioning may be occur. So to avoid this, most of the users or a programmer designer, we say, make an facility that at the time of power on, your system will be resetted. Okay. So this is related to the PCON register. Only 2 bits are there and remaining bits are not used or utilized now. Okay. So write this register, that is PCON, draw the format. Only 2 bits are there. Both are readable as well as writable, R oblique W. And initial step is mentioned. For BOR is 1 and POR is 0. So mention bar specifically, active low. Please draw this. Don't put your roll numbers in chat box. I will take attendance afterwards. And related to, as per practicals concern, we have firstly seen that how the kill works. That is introduction to kill microcontroller. This is our first experiment. After that, arithmetic operations. So various arithmetic operations like addition, subtraction, division, multiplication. Okay. As we have seen already. After that, logical operations, that is AND, OR, XOR, NAND, NOT, that is complement. So these are the arithmetic as well as logical operations we have to study. After that, next experiment is block transfer and exchange. I think this is also completed from us, that is transferring the block and exchanging the block with the memory locations. And that too we are we have used indirect addressing mode, that is R0 and R1. Is it correct or wrong? Okay, block transfer and exchange, both we have completed. So this experiment is also completed. After that, we have, I think, used or seen that the timer operation, but timer operations count is only observed, delay generation. We have not, I think, studied the timer registers, right ना? Timer register आपण बघितले नसतील किल मध्ये. फक्त रॅन्डम डिले.
टाइमरचं राहिलं.
हा रॅन्डम डिले जनरेट केला होता आपण R0 255 किंवा FF आणि त्याच्यानंतर LED ब्लिंकिंग ऑफ द LED स्पोर्ट पिन्स. ओके, तर त्याचं आपण ते पाहू नंतर. मला वाटतं आफ्टर दॅट वी हॅव ऑल्सो सीन द सिरियल कम्युनिकेशन एक्सपेरिमेंट ऑल्सो ना. सिरियलचा पाहिलाय ना. डिस्प्लेवर नेम ट्रान्सफरवर नेम काहीतरी यस ट्रान्सफर केलं होतं, तर नेम ट्रान्सफर करायला सांगितले होते.
हा 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 सर, आणि आपलं नेम सी मध्ये पण बघितलं.
ओके गुड. म्हणजे सिरियलचा पण झालंय आपला. याच्यानंतर आपल्याला टायमरचा आहे ते पाहू कधी घ्यायचं काय, आणि मग त्यानंतर LCD आहे आणि कीपॅड आहे. Okay, so near about 5 to 6 experiments we have already covered. We will see again after when you join to the college again itself. Okay, so till now, as this is your practical lecture, na? Practical session is this today. See, this chapter is most important as architecture and most of the SFRs working included in this chapter. After that, working of IO ports maybe in next chapter, I think. So various SFRs, how they are working, the bit size, initial status, readable, writable, okay, and for which operation these SFRs are used, which is most important as far as we are concerning to the PIC 16F877 microcontroller. So study carefully for the specific SFRs. We are not taking all the SFRs available in the PIC 16F, but the SFRs which are mostly used in a basic programming, and most of the times repetitively these SFRs are required or needed. These SFRs we are going to study, like option status, INTCON, this is PCON, and after that for memory operations, various EECON 1, EECON 2, same register is there.
Completed, sir.
Okay. So after this, we will go for the next, that is SFRs used for accessing the flash program memory and E square PROM data memory. Okay. So some specific SFRs, that is registers, are used for accessing this memory. And these registers are ECON, that is E square PROM. Con means control, control 1, control 2, EE data, that is for lower 8 bit. After that, EE data H for higher 8 bit. EE address, that is ADR means address for related to the accessing address of lower 8 bits, and EE ADR EH for accessing higher 8 bits of the address. So these registers, or we simply say that the SFRs, are used to access E square PROM and flash type of program memory. And these registers are not included in the मेमरी स्ट्रक्चर्स ऑफ फाईल रजिस्टर्स. हे फाईल रजिस्टर मध्ये नसणार, हे काय स्पेशल रजिस्टर आहेत, आणि विथ द हेल्प ऑफ दीज रजिस्टर्स वी आर एबल टू access both memories, E square PROM as well as flash type of memory, that is program memory. Okay, and the RAM address 368 bytes, which is accessed with the help of FSR. आपण म्हटलं ना फाईल रजिस्टर आहे आर्किटेक्चर मध्ये FSR. तो FSR रजिस्टर जो आहे किंवा आपण जो मेन्शन करणार ऍड्रेस, तो कुठला ऍड्रेस मेन्शन करणार, तर डेटा मेमरीचा म्हणजेच रॅमचा. जसं की आपण R0 R1 R2 हे 805 मध्ये यूज करत होतो फॉर टेम्पररी storing the data or temporary accessing the data. Similar to this, we use here for accessing data memory FSR, file register, file status register, data memory साठी. रजिस्टर बँक सारखंच. जसं रजिस्टर बँकला पण स्वतःच काही नव्हतं, म्हणजे R0 ला काही कंटेंट नव्हते. R0 चे 8 चे 8 बिट ब्लँक, जसं की एस बप आहे तसंच, R1 चे तसंच, R7 चे तसंच. आणि दिस इज सिमिलर फॉर 4 रजिस्टर बँक, दॅट इज बँक 0 1 2 3. हे 8051 मध्ये होतं, ब्लँक रजिस्टर आपल्याला एमटी मिळत होतं, त्याच्यामध्ये आपण डेटा लोड करणार आणि पाहिजे तसं ऑपरेट करणार. मूव ए कॉमा R2, मूव R5 कॉमा बी, लाईक दॅट. ओके, हे आपण ट्रान्सफर करत होतो कंटेंट विथ द हेल्प ऑफ दिस. आता याच्यानंतर जसं की आपण आता पीक मध्ये कन्सिडर करतोय, पीक मध्ये जर डेटा मेमरी ऍक्सेस करायची असेल तर तुम्हाला यूज करायचे FSR, दॅट इज फाईल रजिस्टर. ओके, फाईल स्पेसिफिक रजिस्टर. आणि तिथं मेमरी कुठली असणार आहे, तर रॅम असणार आहे. 368 टोटल जी अवेलेबल आहे त्यातली ती रॅम मेमरी असेल फाईल रजिस्टरला. आणि आता आपल्याला ऍक्सेस कुठली करायची, तर प्रोग्राम मेमरी, दॅट इज फ्लॅश प्रोग्राम मेमरी ऍज वेल ॲज E2 PROM. आता ही एक परमनंटच मेमरी आहे, फक्त यूज करणारे टेम्पररी ऍप्लिकेशन साठी. ह्या दोन जे काही E2 PROM आणि फ्लॅश प्रोग्राम आहे, तर ह्या दोन मेमरीज ज्या आहेत त्या कुठे यूज करणार आहे आपण, सॉरी त्या ऍक्सेस कसे करणार आहे, तर विथ द हेल्प ऑफ दिस मेन्शन रजिस्टर, दॅट इज ECON 1 2. Similar application for of con 1 and con 2. So we will discuss only one which is similar to the con 2 or vice versa. After that, these 4 registers. So these 4 registers, 2 for data and 2 for address. 2 for data means to access lower 8 bit, we will use EE data. And for accessing higher 8 bits, we will go for EE data H, that is DATH. Okay, and for accessing address, similar to this, for accessing lower 8 bits we will go for EEADR, and for accessing higher 8 bits of address, in that case we go for EEADRH. So these registers are used to access these two memories, that is flash program memory and E2 PROM memory. Okay, so we will see one by one. So just note down these few points related to the registers available or used for accessing flash memory and E2 PROM memory. Okay, please. Completed?
No, sir. Completed, sir.
Okay. So as we have seen the various register, we will go one by one in detail. So see, most important in that is econ 1 and 2, same register is there here. So we have mentioned combinedly, that is econ 1 and 2, that is both register econ 1 and econ 2 registers. Here this is an 8-bit register. Most of the bits are readable as well as writable. Okay. So in this case, we will see the various flags or bits associated with these register. Okay. So if we consider first, that is whether we have accessing the program memory, that is flash program memory, or we are accessing data memory, that is E square P ROM. In this case we consider as a data memory. Okay, हे क्लिअर आहे ना? ई स्क्वेअर पी रॉम जी आपल्याकडे आहे 256 बाइट्स, याला आपण डेटा मेमरी म्हणणार आहे की प्रोग्राम मेमरी, as per the specifications given in the PIC microcontroller, that is PIC 16F877. ही कशी ट्रीट करणार आहे आपण ई स्क्वेअर पी रॉम? हॅलो, hello,
Data memory.
I am audible? Data memory, as we have seen in the specification, that program memory is the size of 8 kilobyte, and that too the flash type of program memory. And when we mention the E square P ROM, before writing E square P ROM, it is already mentioned that data E square P ROM. बरोबर आहे का बघा? E square P ROM लिहिताना आपण त्याच्या अगोदर एक वर्ड यूज केला, डेटा E square P ROM, right? Means we are using here 256 bytes of E square P ROM as data memory. So here when we consider or select either program or data memory, in that concern we have to select either flash type of program memory with the size of 8 kilobyte, and data memory is E square P ROM 256 bytes. Are you clear with this concern?
Yes, sir.
Hello. Okay, so here we are going to use the bit 7, that is EEPGD, that is program oblique data E square P ROM select bit. So for selection of this, we are going to use this EEPGD bit, and if we use or make this bit as a 0, in that case E square P ROM is act as a data memory, and whenever we require or additional memory along with the flash type of program memory, in that case you have to specify that EEPGD is equal to 1, so that it will act as a program memory. Okay, if it is additionally required in that case. So for this purpose we have to use this bit, that is EEPGD, either data either program. Okay, After that, next 3 bits are not used till now. Then next is WRERR. Okay, WR, we generally use the term WR for write and RD for read. So here WRERR, ERR means error. Okay, so here error detection or error checking flag is there. So whenever we perform the write operation on the E square P ROM, whenever we perform write operation on E square P ROM memory, in that case, if write operation is not completed successfully, if write operation is not completed successfully, in that case, this bit sets to the 1. Okay, that is when your write operation is terminated prematurely. Terminated prematurely in the sense of बिफोर कंप्लिशन, म्हणजे जेव्हा सक्सेसफुल कंप्लिशन व्हायला पाहिजे की जेवढं काय राईटचा डेटा आहे, सपोज 256 मधला 200 बाइट्स तुम्हाला राईट करायचे, बट 100 बाइट्स राईट झाले आणि पुढचे 100 राईट करायच्या अगोदरच काय झालं, तुमचे सिस्टीम टर्मिनेट झाली किंवा पॉवर ऑफ झाली, ब्राउन आउट रिसेट असेल, POR असेल, व्हॉट एव्हर. ओके, मग या केसमुळे किंवा मास्टर रिसेट असेल, या केसमुळे काय होईल, तुमचं राईट ऑपरेशन कंप्लीट होणार नाही, एरर येईल तिथं. तो एरर म्हणजे राईट ऑपरेशन कंप्लीट झाले की नाही हे कोण डिसाइड करेल किंवा कसं आपण ऍज अ युजर कसं आयडेंटिफाय करायचंय, तर टू ऑब्झर्व द WRERR बीट. ते काय करायचंय, WRERR बीट ऑब्झर्व करायचंय. जर WRERR बीट 0 असेल तर याचा अर्थ आहे की आपण जे काही राईट ऑपरेशन परफॉर्म करत होतो ते कंप्लीट झाले, त्याच्यामध्ये कुठल्याही प्रकारचा इंटरप्ट आलेला नाही, इंटरप्ट म्हणजे ऑब्स्टॅकल आलेला नाहीये किंवा ते सक्सेसफुली रिटर्न ऑन दॅट पर्टिक्युलर मेमरी. बट इफ समथिंग हॅपन्स ड्यू टू दॅट, बिफोर टाइम इन द सेन्स ऑफ सगळा डेटा राईट करायच्या अगोदर बंद झालं, स्टॉप झालं, त्याला वर्ड काय यूज केलाय, प्रीमॅच्युअरली. प्रीमॅच्युअरली जर टर्मिनेट झाला असेल तर ते बीट काय होईल, 1 होईल. लक्षात येते बघा. सो whenever WRERR sets to the 1, it will indicates that your write operation is not completed successfully. आपण असं पण म्हणू शकतो की तुमचं राईट ऑपरेशन सक्सेसफुली कंप्लीट झाले नाही, म्हणजेच काय झालं, प्रीमॅच्युअरली टर्मिनेट झालं. लाईक त्यांनी दिलं एक्झाम्पल मध्ये बघा, MCLR म्हणजे मास्टर रिसेट आहे किंवा वॉचडॉग टायमर रिसेट झाला, तुम्ही एक टायमर डिफाईन केलाय, त्याच्यानंतर तुम्ही काय करताय, सिस्टीम रिसेट करताय, त्या केसमध्ये पण रिसेट होऊ शकतं. तर हे डिटेक्शन साठी काय आहे तुमचं, WRERR, एरर डिटेक्शन बीट, राईट एरर डिटेक्शन बीट किंवा फ्लॅग. हे 0 आहे तेच गुड असतं, म्हणजे तुमचं राईट ऑपरेशन व्यवस्थित कंप्लीट झालंय जर 0 असेल तर. आणि 1 झालं याचाच अर्थ काय झालं, तुम्हाला यू हॅव टू परफॉर्म द राईट ऑपरेशन 1 मोर टाइम. ओके, म्हणजे पुन्हा एकदा अगेन यू हॅव टू राईट द कंटेंट ऑन द सेम मेमरी. परत एकदा तुम्हाला ते कंटेंट काय करावे लागतील, राईट करावे लागतील. आर यू गेटिंग WRERR बीट when it is 0, when it is 1?
Yes, sir.
Okay, so after that we go for write enable. WREN enable. So E square P ROM write enable बीट, म्हणजे त्याच्यावरती आपल्याला डेटा राईट करण्याच्या अगोदर त्याची परमिशन किंवा ते ऍक्सेस अलाउ करावं लागते. त्यासाठी काय करावं लागते, मग तुम्हाला ते 1 करावे लागेल. सो whenever we make WREN is equal to 1, then and then only we are able to write the content on E square P ROM. Otherwise we are not capable to write the contents on E square P ROM. So whenever you want to use E square P ROM, okay, in that case you should make E square P ROM bit, that is WREN is equal to 1. So when we make WREN is equal to 1, in that case only we are able to write the content on E square P ROM. Otherwise जर तुम्हाला ते नको असेल, in that case you should make 0, inbuilt write to the E square P ROM. इनबिल्ट राईट म्हणजे काय, जे ऑलरेडी अवेलेबल असेल तेच. म्हणजे तुम्ही वन टाइम प्रोग्राम वगैरे केला किंवा काय काय आपण प्रोग्राम म्हणून यूज केला आणि त्याचं मॉडिफिकेशन नको आहेत, जसं की कस्टमर एंडला तुम्ही काही प्रोडक्ट्स देता त्याच्यामध्ये आपण मॉडिफाय करू शकत नाही. सो नो मॉडिफिकेशन. सो इन दॅट केस you should go with this pattern. Okay, So make this bit 0. Clear hai हे bit enable. Hello.
Yes, sir.
Remaining candidates, you also need to talk or respond. Shall I go with the roll numbers random? After that, we will go for the next WR and RD. So WR means write control, that is write cycle, and read control, read cycle. So when this WR is equal to 0, then write operation is completed. And when this bit is 1, that is WR is equal to 1, it will indicates that write cycle has been started or not completed yet. Right cycle has been started or not completed yet. WR जर 0 असेल तर काहीच नाहीये की बाबा एक तर राईट सायकल कंप्लीट झाली किंवा ती चालूच झाली नाही जर WR इज इक्वल टू 0 असेल तर. पण WR इज इक्वल टू 1 मीन्स काय असेल इथं की राईट ऑपरेशन गोइंग ऑन इन प्रोग्रेस, आत्ताच चालू झालंय किंवा ते चालू आहे असा अर्थ घ्यायचा त्याचा. ओके, इनिशिएट्स अ राईट सायकल. जर ते चालू असेल तरच ते 1 असेल, अदरवाईज ते काय असेल 0 असेल. एक लक्षात ठेवा. म्हणजेच काय असेल एक तर कंप्लीट झाल्यावरती पण 0च बनतं आणि चालूच झालं नसेल तरी पण 0च बनतं. त्यासाठी एक सिंपल सेंटेन्स आपण लक्षात ठेवू की राईट ऑपरेशन चालू असेल इन प्रोग्रेस असेल तेव्हा ते 1 असतं, अदरवाईज इट इज 0. सिमिलर टू द रीड. आता रीड पण तसंच आहे. रीड 0 कधी असेल, डज नॉट इनिशिएट अँड ई स्क्वेअर पीरॉम रीड. 0 आहे म्हणजे त्यांनी रीड करायची कंडिशन चालू केलेली नाही, म्हणजे नॉट इनिशिएटेड द रीड कंडिशन. रीड म्हणजे ई स्क्वेअर पीरॉम आपल्याला रीड करायचे कंटेंट, त्याचे ऑब्झर्व करायचे काय काय कंटेंट स्टोअर आहेत ते, तर ते रीड ऑपरेशन असेल. मग त्या केसमध्ये काय असेल, हे बिट आरडी जर 0 असेल तर काय आहे तिथं की आपण रीड ऑपरेशनची कमांड दिलेली नाही ई स्क्वेअर पीरॉम. पण जर रीड ऑपरेशन आपलं रीडिंग चालू आहे, आपलं मीन्स सीपीयू, इफ सीपीयू इज कंटिन्यूइंग विथ द रीडिंग प्रोसेस, that is reading the data from e square pyram, in that duration only rd is equal to 1. जोपर्यंत रीडिंग चालू आहे तोपर्यंत आरडी काय असेल तुमचा 1 असेल. क्लियर आहे?
Yes, sir.
Okay, so you start with this writing format con 1 and con 2, right, in combinedly con 1 and con 2.
Completed, sir.
Okay, so we'll go for next bits. So you should mention this also, read oblique write. X means initial status don't know, and it is initially 0.
Completed, sir.
Okay, so we'll go for this register in next lecture. So till now we'll go for the attendance.